You step outside on a clear, freezing night and look up, instinctively believing that the canopy of stars above you is a reflection of the present moment. It is an illusion, a localized deception born of biological arrogance. Human eyes, evolved to spot predators in the tall grass, are simply not equipped to process the sheer, terrifying latency of the cosmos. Every single photon striking your retina is a ghost. It is a fragile remnant of a star that may have exhausted its nuclear fuel and collapsed into a crushing singularity eons before the first oceans even began to form on Earth. You are not observing the universe as it is. You are wandering blindly through a museum of dead light. For generations, we found a fragile comfort in our local neighborhood. We cataloged nearby planetary bodies, measured distances in mere millions of miles, and constructed a narrative where humanity sat at a reasonably significant vantage point, looking out at a static, manageable void. But that comforting lie was systematically dismantled the moment the gold-plated beryllium mirrors of the James Webb Space Telescope fully aligned in the absolute zero darkness of Lagrange Point 2, suspended a million miles from the safety of our world. This machine was not designed simply to capture sharper photographs of familiar constellations. It was engineered with a far more ruthless purpose: to pierce the obscuring molecular dust of the cosmos and capture the faint, stretched infrared echoes from the dawn of time. What it ultimately found was not a gentle, sparsely populated expanse waiting to be explored, but a violent, hyper-dense architecture of ancient galaxies that defies human comprehension. In a single patch of sky, a fraction of the void no larger than a grain of sand held at arm's length against the night, the telescope revealed thousands upon thousands of entire galaxies, trillions of massive thermonuclear furnaces, countless billions of untethered worlds. The sheer crushing scale of this single observation does not just diminish us. It effectively erases our mathematical significance entirely. We are now forced to confront the absolute certainty that our entire planetary history, our empires, and our greatest technological achievements amount to infinitely less than a statistical rounding error in the relentless machinery of the universe. To truly understand the cosmos is to accept a profound and isolating truth about our fleeting place within it. The mechanics of the universe operate with a cold, unforgiving precision, entirely unaware of our existence. If you are prepared to shed the fragile comforts of human intuition, to confront the terrifying architecture of reality, and to seek the raw truth hidden in the deep dark, subscribe and join us on this journey. We are going to deconstruct the boundaries of the observable universe, peering into the ancient abyss to understand exactly how this machine proved that we are nothing. To understand the magnitude of the deception we are living under, we must first dissect the fundamental flaw in our own biological wiring. The human brain is a magnificent, highly specialized survival engine, but it is entirely localized. We evolved on the plains of a rocky terrestrial planet, learning to calculate the trajectory of a thrown spear, the sudden movement of a predator in the brush, the immediate cause and effect of gravity and momentum. Because of this localized evolution, we perceive reality through a strict, unforgiving lens of absolute synchronicity. When you drop a glass, it shatters on the floor, and the sound reaches your ears at what feels like the exact same moment your eyes process the physical destruction. This immediate feedback loop convinced our ancestors that the universe operates in a universal now. It created an intuitive certainty that what we see is exactly what is happening in the present tense. That biological intuition is the greatest lie we have ever told ourselves. In the grand architecture of the cosmos, the present tense does not exist. It is a mathematical impossibility. The universe operates on a system of agonizing, inescapable latency, much like a planetary computer network, where the servers are separated not by miles, but by vast, empty oceans of deep time. The limiting factor in this system is the speed of light. In a vacuum, a photon travels at precisely 299,792,458 meters per second. To a primate standing on a rock, that speed seems infinite, instantaneous. But against the sprawling, hostile void of the cosmos, the speed of light is a sluggish, pathetic crawl. When you look at the moon, you are not seeing the moon as it is. You are seeing a ghost from 1.3 seconds ago. You are witnessing the time it took for the sunlight to bounce off the lunar regolith and cross the 238,000 miles to strike your optic nerve. When you feel the warmth of the sun on your skin, you are absorbing radiation that left the solar surface 8 minutes and 20 seconds prior. If the sun were to magically extinguish right this very second, we would continue to orbit a dead star in blissful, sunlit ignorance for over 8 minutes before the sky went black and the gravitational tether snapped. The further out you look, the deeper into the past you fall. The nearest star system, Alpha Centauri, is 4.2 light-years away. If that star went supernova today, it would take 4 years for the light of its destruction to reach our telescopes. We are permanently isolated in our own localized bubble of time, receiving nothing but delayed messages from a universe that has already moved on. For millennia, humanity was completely oblivious to this temporal prison. We looked up at the night sky and saw a flattened, two-dimensional dome. The ancient Greek astronomer Claudius Ptolemy codified this comforting illusion in the 2nd century, proposing a geocentric universe wrapped in crystalline spheres. The stars were fixed, glowing pinpricks on the ceiling of our terrestrial nursery. It was an intimate, closed system designed by a creator who placed us firmly at the center of the narrative. Even when Copernicus and Galileo shattered the crystalline spheres and violently displaced Earth from the center of the solar system, the human ego simply expanded the boundary of its arrogance. By the late 19th century, the prevailing scientific consensus was that the entire universe consisted solely of the Milky Way galaxy. The cosmos was thought to be a static, quiet disk of stars, drifting in an infinite, timeless dark. That comforting paradigm was brutally executed in the winter of 1923 by a solitary astronomer named Edwin Hubble, freezing in the unheated cage of the Hooker telescope on Mount Wilson. Hubble was photographing faint, swirling smudges of light known then as spiral nebulae, which most scientists believed were simply clouds of gas within our own galaxy. But Hubble was utilizing the recent brilliant mathematical framework laid down by Henrietta Swan Leavitt, a woman who had figured out how to measure astronomical distances by observing the rhythmic pulsing of Cepheid variable stars. Leavitt's mathematics were the key to picking the lock of the universe. When Hubble found a Cepheid variable pulsing inside the Andromeda Nebula, he did the cold math. The numbers were irrefutable, and they were terrifying. Andromeda was not a cloud of gas inside our neighborhood. It was an entirely separate island universe containing 1 trillion stars, located millions of light-years away. Overnight, the size of the known universe expanded by a factor of millions. The sky was no longer a ceiling, it was an open window looking out over an endless falling abyss. But Hubble's true nightmare was yet to come. By analyzing the light spectrum emitted by these newly discovered galaxies, astronomers realized that almost every single one of them was shifting toward the red end of the light spectrum. This is where the physics of our universe transitions from merely vast to outright hostile. Light travels in waves, and just like the sound of a passing ambulance siren drops in pitch as it speeds away from you, a phenomenon known as the Doppler effect, light waves behave identically. If a galaxy is rushing away from us, the physical waves of light it emits are stretched out across the expanding fabric of space-time. As the wave stretches, its frequency drops, and its color shifts toward the longer wavelengths of red. The further away a galaxy is, the faster it is receding, and the more violently its light is stretched. This cosmological redshift was the smoking gun of the Big Bang. It proved that the universe was not static. It was exploding outward in every conceivable direction, carrying everything away from everything else in a relentless, silent expansion. This stretching of space-time is the exact mechanical barrier that blinded us for a century, and it is the precise reason the James Webb Space Telescope had to be built. When astronomers attempt to look into the absolute deepest, most ancient corners of the universe, they are trying to see the very first galaxies that ignited out of the primordial hydrogen gas, roughly 13.5 billion years ago. But because the universe has been expanding for 13.5 billion years, the light from those embryonic galaxies has been traveling through a vacuum that is actively stretching beneath it. By the time those ancient photons finally reach our solar system, their wavelengths have been stretched so radically that they are no longer visible to the human eye. They have been dragged completely out of the visible spectrum, past the red, and dumped into the invisible realm of infrared light. You cannot see the dawn of time with an optical telescope, no matter how massive its mirrors are. The Hubble Space Telescope, a marvel of 20th century engineering, spent decades staring into the dark, but it was physically blind to the oldest light. To see the beginning of reality, you do not need to look for light. You need to look for ancient, freezing heat. The James Webb Space Telescope is not a camera in the traditional sense. It is a hypersensitive thermal receptor floating in the freezing graveyard of space. To capture the dying infrared whispers of the first stars, the machine's architecture had to defy the thermal noise of our own solar system. It features a primary mirror composed of 18 hexagonal segments of beryllium, a rare, incredibly stiff metal that retains its shape in the bitter cold. These mirrors are coated in a microscopically thin layer of pure gold, exactly 100 nanometers thick, totaling merely 48 grams for the entire observatory. Why gold? Because in the cold, hard physics of the electromagnetic spectrum, gold is the most efficient reflector of infrared radiation in the known universe. But there is a lethal engineering paradox. Because Webb is designed to detect the faintest traces of heat from 13 billion light-years away, the telescope itself must be colder than the void it is staring into. If the mirrors or the scientific instruments were even slightly warm, the telescope's own thermal radiation would completely blind its sensors, like trying to spot a firefly in the beam of a military searchlight. To solve this, Webb is equipped with a 5-layer sunshield the size of a tennis court, constructed from Kapton, a specialized polyamide film. This shield physically blocks the nuclear fury of our sun, the glare of the Earth, and the reflection of the moon. On the sun-facing side, temperatures boil at 230 degrees Fahrenheit. Just a few feet away on the dark side of the shield, the gold mirrors operate in a permanent, engineered winter of minus 390 degrees Fahrenheit. It is a machine of pure isolation, sitting a million miles away, holding its breath in the freezing dark, waiting for the ghosts to speak. And when those mirrors finally aligned, when the instruments calibrated to the absolute zero silence of the Lagrange point and stared into a seemingly empty patch of black sky, the data that began bleeding back to Earth did not align with our carefully constructed cosmological models. The math began to crack. The images processed by the team at the Space Telescope Science Institute revealed something lurking in the deep infrared that simply should not have had the time to exist. The prevailing assumption regarding the infancy of the universe was a story of agonizingly slow, violent progression. Cosmologists and astrophysicists had spent decades constructing a robust, mathematically beautiful framework known as the lambda cold dark matter model. In this model, the narrative of creation is methodical. After the initial hyper-expansion of the Big Bang, the universe was a blindingly hot, opaque soup of subatomic particles. As it expanded, it cooled. Roughly 380,000 years after the beginning, the temperature dropped enough for the first electrons to bind with protons, creating the very first atoms of neutral hydrogen. This event released the first flash of light, the cosmic microwave background, but it also plunged the universe into an era known as the Cosmic Dark Ages. There were no stars, there were no galaxies. There was only a sprawling, expanding fog of primordial hydrogen gas drifting through a pitch-black void, completely devoid of any light source. For the universe to build a galaxy, it required time, and it required an invisible architect. The Standard Model dictates that the physical structure of the cosmos is dictated by dark matter, a mysterious, non-luminous substance that makes up roughly 85% of all the mass in the universe. We cannot see dark matter, but we can measure its gravitational tyranny. During the Dark Ages, this dark matter began to pool together, forming immense, invisible gravitational wells known as halos. Over hundreds of millions of years, the sheer gravitational pull of these dark matter halos began to drag the drifting clouds of neutral hydrogen gas inward. As the gas fell into these invisible gravity wells, it compressed, heated up, and eventually, in the densest, most pressurized pockets of this collapsing gas, nuclear fusion ignited. The first generation of stars, known as Population 3 stars, roared to life. They were massive, short-lived, and utterly isolated. According to the ironclad mathematics of the lambda cold dark matter model, This process of building structure is strictly hierarchical. It is a bottom-up assembly line. Small things form first. The first stars bind together to form small, messy, chaotic dwarf galaxies. Over billions of years, these dwarf galaxies drift toward one another, colliding, tearing each other apart, and merging in a violently slow cosmic ballet to eventually form the majestic, swirling spiral galaxies we see in our modern local universe, like our own Milky Way. Building a massive galaxy is like building a continent through plate tectonics. It is a process defined by deep geological timescales. Our models dictated that if we looked back to the very dawn of time, specifically to the first 500 million years after the Big Bang, we should only see the weak, fragmented, chaotic sparks of infant proto-galaxies struggling to take shape in the darkness. But when the James Webb Space Telescope opened its golden eye and peered into that ancient darkness, it did not find a quiet nursery of struggling proto-galaxies. It found an established, hypermassive, fully functioning cosmic metropolis. In a series of deep field observations, specifically within surveys like the Cosmic Evolution Early Release Science Program and the JWST Advanced Deep Extragalactic Survey, the telescope identified objects that immediately sent a shockwave through the global astronomical community. The data revealed a collection of galaxies existing a mere 300 to 400 million years after the Big Bang. But it was not their age that broke the mathematics. It was their impossible scale. These galaxies were not chaotic smudges of infant stars. They were highly structured, incredibly luminous, and contained stellar masses ranging from 10 billion to 100 billion times the mass of our Sun. To put this temporal and physical paradox into perspective, imagine an archaeologist digging into the strata of the Earth, seeking the earliest evidence of human civilization. They dig past the Iron Age, past the Bronze Age, deep into the Paleolithic era, hoping to find scattered, rudimentary stone tools or a primitive fire pit. Instead, perfectly preserved in the rock from 2 million years ago, they uncover the sprawling, neon-lit skyline of modern Tokyo. It is not just an anachronism, it is a physical impossibility that destroys the entire assumed timeline of development. You cannot build a 100 billion solar mass galaxy in 300 million years. The universe simply did not have enough time to pull that much raw material together. In the physical world, there are strict limits on how fast gas can cool and collapse to form stars. This is known as the star formation efficiency rate. In our local universe and in every mathematical simulation we have ever run, galaxies are horribly inefficient at turning gas into stars. The energy released by supernovae and stellar winds constantly blows the necessary star-forming gas back out into deep space, choking off the galaxy's growth. To achieve the mass observed by the James Webb Space Telescope in such an impossibly short time frame, these ancient galaxies would have had to convert nearly 100% of their available gas into massive stars instantly, completely bypassing the known laws of thermodynamics and gravity. It is the equivalent of a modern skyscraper assembling itself from dust and raw iron ore in a matter of seconds. The initial reaction from the scientific establishment was one of profound skepticism. The implications were too destructive to accept blindly. When an observation fundamentally shatters the established paradigm of physics, the first assumption is always that the instrument is flawed or the data is being misinterpreted. Astronomers questioned whether these galaxies were truly as distant as they appeared. Perhaps they were smaller, dimmer galaxies located much closer to Earth, masquerading as ancient giants due to heavy cosmic dust obscuring their true optical signature. To prove the impossible, the James Webb Space Telescope had to rely on its most complex and ruthless piece of engineering, the near-infrared spectrograph, or NIRSpec. Taking a photograph of a red dot in the deep field is not enough to measure its distance. You must dissect the light itself. NIRSpec does this by breaking the incoming infrared light from a galaxy into its component wavelengths, creating a physical barcode of the object's chemical composition and its exact distance. But isolating the light of a single, impossibly faint galaxy located 13 billion light-years away, while ignoring the blinding glare of billions of other stars and galaxies in the foreground, requires a mechanical precision that borders on the absurd. To achieve this, engineers equipped NIRSpec with a microshutter array. This is a grid consisting of nearly 250,000 microscopic doors, each measuring a mere 100 by 200 microns, roughly the width of a human hair. By sending a magnetic signal, the telescope can command specific individual doors to open, allowing only the light from a targeted ancient galaxy to enter the spectrograph, while keeping the rest of the universe locked out in the dark. Once the light passes through the microshutter, it is split into a spectrum, and scientists look for a very specific, undeniable mathematical signature: the Lyman alpha break. Hydrogen gas permeates the universe, and it has a strict physical property where it completely absorbs ultraviolet light at a very specific wavelength, 91.2 nanometers. This creates a hard, undeniable cliff in a galaxy's light spectrum, a dead zone where no light passes through. Because the universe is expanding and the light from these early galaxies is being stretched over billions of years, this absorption cliff is dragged out of the ultraviolet and pushed deep into the infrared. By measuring exactly where this cliff falls in the infrared spectrum captured by Webb, astronomers can calculate the exact cosmological redshift of the galaxy. It is a measurement that cannot be faked by dust or optical illusions. The microshutters opened, the light was dissected, the Lyman breaks were measured, and the results were absolute. The redshifts were confirmed at values of 10, 11, and even 13. The math was not lying. The instrument was not flawed. These impossible, hypermassive galaxies were exactly where they appeared to be, residing in the first few 100 million years of reality. The data solidified the terrifying realization that our understanding of how matter behaves on a cosmic scale is deeply, fundamentally broken. The universe did not slowly awaken from the Dark Ages. It exploded into brilliant, massive structure with a speed and violence that our current physics cannot explain. But the structural impossibility of these early stars is only a fraction of the nightmare Webb uncovered. Hidden within the core of these ancient, massive galaxies lies a far more sinister anomaly, one that actively defies the mechanical limits of gravity and radiation. At the center of nearly every massive galaxy in the universe, including our own Milky Way, resides a supermassive black hole. These are gravitational titans, regions of space where matter is crushed to infinite density, weighing millions or even billions of times the mass of our Sun. The standard cosmological model provides a relatively straightforward, albeit slow, mechanism for how these monsters form. They begin as stellar mass black holes, the collapsed dead cores of the very first massive stars. These seeds are small, perhaps a few dozen times the mass of the Sun. Over billions of years, these seeds slowly consume surrounding gas, dust, and other stars, steadily growing in mass. However, black holes cannot eat instantly. The universe has enforced a strict speed limit on their consumption, known as the Eddington limit. As a black hole's gravity pulls gas inward, the gas forms a swirling accretion disk around the event horizon. This gas is compressed and heated to millions of degrees, causing it to emit blinding amounts of radiation. This outward pressure of radiation physically pushes back against the inward pull of gravity. If a black hole tries to consume matter too quickly, the intense radiation from its own accretion disk blows the surrounding food source away, starving the black hole and halting its growth. Because of the Eddington limit, it takes an agonizingly long time, billions of years of steady, regulated feeding, for a small stellar seed to grow into a supermassive black hole. The James Webb Space Telescope stared into the early universe and found fully mature, supermassive black holes containing 1 billion solar masses, existing just a few 100 million years after the Big Bang. This is not just an anomaly, it is a violation of the mechanical laws of accretion. To reach 1 billion solar masses in that time frame, a black hole would have to feed continuously, at the absolute maximum Eddington limit, without a single interruption, from the very moment the universe was born. And even then, the mathematics barely hold together. The timeline is too compressed. The speed limit of physics is too slow. Astrophysicists are now scrambling to draft theories to patch the bleeding hole in our understanding of reality. Some propose the existence of heavy seeds. The idea that massive clouds of primordial gas somehow bypassed the star formation phase entirely, collapsing directly under their own immense weight to form an instant black hole tens of thousands of times the mass of the Sun. Others suggest that in the extreme, chaotic density of the early universe, the Eddington limit was somehow temporarily broken, allowing these black holes to gorge on matter at a rate that is currently impossible in our modern cosmos. We are left staring at a celestial architecture that we cannot explain. We built a machine to peer into the past, expecting to find the simple, chaotic beginnings of our long evolutionary lineage. We expected to find a universe that made sense, a universe that obeyed the slow, majestic physics we painstakingly deciphered over centuries. Instead, the James Webb Space Telescope has dragged us out of our intellectual comfort zone and forced us to look at a dark, ancient machinery that operates on rules we do not possess. The deep void is not an empty historical record waiting to be cataloged. It is an actively hostile environment of impossible mass, crushing gravity and terrifying speed, entirely indifferent to the biological organisms trying to measure it. We are standing on the edge of an abyss, holding a mirror up to the dark, and the reflection we are seeing is not our origin story. It is a testament to our profound ignorance. For over 3 centuries, humanity operated under a comforting delusion regarding the nature of mathematics. We convinced ourselves that the equations we scratched onto chalkboards were the fundamental source code of reality. From the orderly, predictable elliptical orbits of planets mapped by Isaac Newton to the elegant, curving geometry of space-time visualized by Albert Einstein, we believed that if we could just balance the numbers, the universe would be forced to reveal its secrets. Mathematics was our ultimate weapon against the unknown, a logical tether that made us feel powerful, relevant, and capable of domesticating the infinite. But the James Webb Space Telescope did not just find anomalous stars in the deep field. It found the exact coordinates where our mathematics begin to bleed, fracture, and ultimately fail. We have hit a terrifying theoretical wall, a point where the fundamental laws of physics we rely on to understand our own existence are entirely irreconcilable with the violent reality of the cosmos. To comprehend the scale of this scientific crisis, you have to understand the pulse of the universe. The cosmos is not a static, empty room. It is a living, expanding membrane, and the rate at which it is stretching apart is known as the Hubble constant. For astrophysicists, measuring the Hubble constant is not just an academic exercise. It is the single most important number in the universe. It dictates the age of reality, the total mass of all existing matter, and the ultimate, inescapable fate of everything. If you know how fast the universe is expanding, you can run the tape backward to the Big Bang, or run it forward to the end of time. For decades, we have possessed 2 highly precise, mathematically rigorous methods for measuring this expansion rate. The first method involves looking at the absolute oldest light in existence, the cosmic microwave background. This is the thermal afterglow of the Big Bang, a faint radiation pattern permanently burned into the sky when the universe was just 380,000 years old. By using instruments like the European Space Agency's Planck satellite to map the microscopic temperature fluctuations in this ancient radiation, cosmologists can observe the density of the early universe. They then take those ancient parameters, plug them into the standard model of cosmology, and mathematically fast-forward 13.8 billion years to predict how fast the universe should be expanding today. The result is incredibly precise. According to the early universe, space is expanding at a rate of 67.4 kilometers per second per megaparsec. The second method involves ignoring the ancient past and measuring the local, modern universe directly. Astronomers do this by tracking objects known as standard candles. These are celestial bodies whose true absolute brightness is governed by strict, unyielding laws of physics. The most reliable of these are Cepheid variable stars, which pulse at a rate directly tied to their luminosity, and type Ia supernovae. A type Ia supernova occurs when a dead white dwarf star slowly cannibalizes gas from a companion star. The moment the white dwarf reaches exactly 1.44 times the mass of our Sun, a strict boundary known as the Chandrasekhar limit, it detonates in a thermonuclear explosion. Because every one of these stars explodes at the exact same mass threshold, they all explode with the exact same blinding luminosity. By comparing how bright the explosion actually is to how dim it appears in our telescopes, we can calculate precisely how far away the host galaxy is. And by measuring its redshift, we can see how fast it is being carried away by the expansion of space. When astronomers run the numbers using these modern exploding stars, the result is equally precise. According to the late universe, space is expanding at a rate of roughly 73 kilometers per second per megaparsec, 67 against 73. To a layman, a difference of a few kilometers per second might seem like a trivial rounding error. In the cold realm of astrophysics, it is a catastrophic reality-breaking paradox known as the Hubble tension. Imagine watching a train leave a station. You have a team of elite engineers at the departure platform who measure the engine's power, the friction of the tracks, and the weight of the steel, predicting exactly when the train will arrive at its destination. You have another team of equally elite engineers at the arrival station, measuring the train's speed as it pulls in. Both teams use flawless, perfectly calibrated instruments. Both teams execute flawless mathematics. And yet the arrival team measures the train moving significantly faster than the laws of physics dictate it should be. The only logical conclusion is that somewhere out in the dark, in the empty miles between departure and arrival, the fundamental laws of motion secretly changed. Before the James Webb Space Telescope launched, the scientific community clung to a desperate hope. They hoped that the Hubble tension was simply a mechanical error, a slight blurring of the lenses in the older Hubble Space Telescope that made the Cepheid variable stars look a little too bright or a little too dim. Webb was engineered to put this debate to rest. With its terrifying infrared resolution, it could pierce the dust of distant galaxies and isolate the light of individual Cepheid stars with surgical, flawless precision. Webb took the measurements. It looked at the standard candles. And the data it returned was a death sentence for our current understanding of physics. The older telescope was not wrong. There was no blurring. There was no mechanical error. Webb confirmed that the discrepancy is absolutely, undeniably real. The early universe and the late universe are operating on different mathematical frequencies. The very fabric of space is expanding faster than the matter and energy inside it can explain. We are being pulled apart by a phantom mechanism that is entirely missing from our equations. We call this missing mechanism dark energy. But do not let the clinical terminology fool you. Dark energy is not a defined substance. It is a linguistic bandage placed over a gaping wound in our knowledge. It is a placeholder word for human ignorance. We know that roughly 68% of the entire universe is made of this force. Yet we have absolutely no idea what it is, how it functions, or where it comes from. The closest we have come to an explanation is the concept of vacuum energy, born from the bizarre rules of quantum mechanics. Quantum field theory dictates that the empty vacuum of space is not truly empty. It is a boiling, chaotic sea of virtual particles, constantly popping into existence and annihilating each other in fractions of a microsecond. This quantum static should generate a baseline level of energy, a repulsive pressure pushing outward on the fabric of space. When theoretical physicists sit down to calculate exactly how much vacuum energy should exist in the universe, using the most rigorously tested equations of quantum mechanics, they get a massive number. But when astronomers look up at the sky and actually measure the rate of cosmic expansion driven by dark energy, the observed number is drastically smaller. The difference between the mathematical prediction and the physical reality is a factor of 10 to the power of 120. That is a 1 followed by 120 zeros. It is mathematically recognized as the single worst prediction in the entire history of theoretical physics. To understand the absurdity of that error, imagine a civil engineer trying to guess the weight of a single grain of sand, and their mathematics leading them to conclude that the grain of sand weighs exactly the same as the entire observable universe. That is the scale of the failure. Our two most successful frameworks of reality, the quantum mechanics that govern the microscopic and the general relativity that governs the macroscopic, are fundamentally incompatible. When we try to merge them to understand the deep universe, the math devolves into nonsensical gibberish. We are trapped in a cosmos governed by forces we cannot calculate, surrounded by an energy we cannot see, dictating a future we cannot predict. And the collapse of our physical models does not end there. In our desperate attempt to apply our localized math to the staggering vastness of the cosmos, We relied on a foundational assumption known as the cosmological principle. This is the cornerstone of modern astrophysics. The principle states that on a large enough scale, the universe is homogeneous and isotropic. This means that no matter which direction you look, and no matter where you are standing in the universe, the distribution of matter should look essentially the same. There is no center. There is no edge. It is a uniform, evenly mixed soup of galaxies. We had to assume this was true. If the universe is not uniform on a grand scale, then the complex equations of general relativity simply cannot be applied to the cosmos as a whole. Without the cosmological principle, our entire mathematical architecture collapses into dust. To maintain this uniformity, physicists calculated a strict structural limit. They determined that no single structure in the universe, no chain of galaxies, no cluster of dark matter, could possibly be larger than 1.2 billion light-years across. Anything larger would disrupt the homogeneity, proving that matter is clumped together in a way that violates the fundamental laws of gravity and expansion. But as our telescopes peer deeper into the abyssal dark, they are not finding a uniform soup. They are finding monstrous, impossible megastructures that mock our physical limits. We found the Sloan Great Wall, a massive formation of galaxies stretching 1.3 billion light-years long. Then we found the Giant Arc, spanning 3.3 billion light-years. And then, lurking in the deep darkness, we identified the Hercules Corona Borealis Great Wall. It is a terrifying, dense filament of interconnected galaxies and dark matter that stretches across 10 billion light-years of space. It takes light itself 10 billion years just to cross from one side of this structure to the other. It is an architectural impossibility. It represents a concentration of mass so violently massive that it physically should not exist. It shatters the cosmological principle entirely. We are realizing with creeping dread that the universe is not a uniform expanse that obeys our neat, symmetrical equations. It is a jagged, chaotic, deeply uneven territory, and we are trying to map a churning ocean using the mathematics of a puddle. This theoretical impasse leads us to the most horrifying physical barrier of all, the cosmic event horizon. Because dark energy is accelerating the expansion of the universe, the very fabric of space is stretching faster and faster. And while Einstein proved that nothing can travel through space faster than the speed of light, there is no physical law preventing space itself from expanding faster than light. Imagine two ships floating on an ocean. They are moving away from each other at a moderate speed. But the ocean itself is expanding, new water constantly flooding in between them, pushing them apart faster than their engines can run. If the ocean expands fast enough, the ships will eventually recede from each other faster than the speed of communication. This is happening right now, in every direction we look. Galaxies located beyond a distance of roughly 14 billion light-years are being swept away from us by the expansion of space at a velocity exceeding 299,000 kilometers per second. They have crossed the cosmic event horizon. They are physically moving away faster than the speed of light. This creates a chilling, insurmountable paradox for the James Webb Space Telescope. When Webb captures the brilliant, hyper-detailed infrared glow of a galaxy from 13 billion years ago, it feels like a triumph of human engineering. We feel as though we are reaching out and touching the ancient past. But the truth is infinitely more isolating. The light we are capturing is a ghost. In the 13 billion years it took that light to reach our mirrors, the physical galaxy that emitted it has been carried away by the relentless expansion of the universe. It has been pushed over the cosmic horizon. It is now receding from us faster than light can travel. Even if humanity survived for 1 trillion years, even if we harnessed the total energy output of 1 billion stars, even if we built vessels capable of traveling at exactly 99.9% the speed of light, and launched them toward those ancient galaxies today, we would never, ever reach them. They are mathematically severed from our reality. The space between us and them is multiplying faster than we could ever cross it. We can see their ancient ghosts, but their physical forms have been permanently quarantined from our existence. The universe is not just indifferent to our curiosity. It is actively erasing its own history. We are standing in a dark room trying to read a book while an unseen force is burning the pages faster than we can turn them. We are mathematically trapped in a localized bubble of space-time, watching the rest of the cosmos accelerate away into an unreachable, freezing void, leaving us completely and utterly isolated. The realization that the universe is actively quarantining itself from our observation forces, a radical reevaluation of what we consider reality. For the entirety of human existence, we have treated the cosmos as an infinite library. We believed that as our technology evolved, as our lenses grew wider and our sensors more sensitive, we would eventually be able to read every single book on every shelf. The discoveries pouring in from the James Webb Space Telescope have violently corrected this assumption. The library is not infinite, and it is actively burning to the ground. The cosmic event horizon is not just a mathematical curiosity. It is a physical boundary line of absolute erasure, and it dictates a terrifying consequence. The sum total of human knowledge has a strict, non-negotiable expiration date. We are not just physically isolated, we are epistemologically doomed. There is a finite amount of information available to us, and with every passing second, distant galaxies cross that threshold, taking their histories, their chemical signatures, and their potential truths with them into the inaccessible dark. We are living in a transient, privileged window of cosmic time, where the grand architecture of the universe is still partially visible. To understand the true horror of this expanding void, you must look forward. Extrapolate the current rate of cosmic expansion driven by dark energy, and the future of reality becomes a landscape of profound, inescapable amnesia. Imagine a theoretical astronomer living in our solar system, or whatever rocky remnant is left of it, 2 trillion years from now. By that point in deep time, the relentless machinery of dark energy will have stretched the fabric of space so aggressively that every single galaxy outside of our immediate gravitational neighborhood will have been dragged far beyond the event horizon. The night sky of the deep future will be completely, suffocatingly empty. There will be no swirling spiral galaxies in the distance. There will be no observable redshift to map. Even the cosmic microwave background, the fading thermal fingerprint of the Big Bang that currently permeates all of space, will be stretched into wavelengths so impossibly long and flat that it will become physically undetectable to any instrument. The universe will effectively wipe its own fingerprints from the crime scene of creation. Because of this erasure, any intelligent civilization that arises in the deep future will be born into a permanent dark age of cosmology. When their scientists look out into the void, they will see nothing but a localized cluster of aging stars drifting in an endless, static blackness. They will have no physical evidence that the universe is expanding. They will have no data to suggest a Big Bang ever occurred, nor will they have any reason to suspect the existence of other galaxies. Their mathematics and their physics will confidently dictate that their local cluster of stars is the entirety of existence, surrounded by an infinite, timeless nothing. And they will be completely mathematically justified in that conclusion, because the universe will have systematically destroyed every single piece of evidence to the contrary. Our current era, this fleeting moment where we can still see the red-shifted ghosts of the early universe, is a temporary, mechanical anomaly. We are witnessing the very last embers of a dying fire before the ashes are completely scattered by the wind. We are among the last generations of observers who will ever know the true scale of the tragedy. As the greater universe accelerates away from us into the dark, we are left to contend with the brutal mechanics of our immediate surroundings. Our galaxy, the Milky Way, is bound by gravity to a small collection of nearby celestial bodies known as the local group. While dark energy is ripping the macrocosmos apart, the localized gravity within our group is strong enough to temporarily resist the expansion of space. But this gravitational tether is not a sanctuary. It is a death sentence of a completely different kind. The Andromeda Galaxy, our massive trillion-star neighbor, is currently barreling toward us at roughly 110 kilometers per second. In approximately 4 billion years, long after our sun has expanded and boiled the oceans of Earth into a sterilized vapor, these two titanic structures will collide. It will not be a sudden, explosive destruction, but an agonizing, slow-motion gravitational mangling that will last for hundreds of millions of years. The delicate spiral arms of both galaxies will be violently torn apart by immense tidal forces. Trillions of stars will be flung out into the freezing intergalactic void, while the supermassive black holes at the center of each galaxy spiral inward, dragging stellar material with them until they eventually merge into a single, unimaginable singularity. When the violence finally subsides, what remains will not be a majestic spiral galaxy. It will be a massive, featureless elliptical swarm of aging red stars, a structure astronomers have preemptively named Milkomeda. This single monolithic galaxy will be our entire universe. Everything else, every other galaxy we have ever photographed, cataloged, or dreamed of reaching, will have vanished past the cosmic horizon. Milkomeda will be entirely alone in the dark, a localized island of fading light surrounded by a terrifying, hyper-expanding emptiness. And as the billions of years drag into trillions, the internal machinery of this final galaxy will slowly begin to fail. The process of star formation is finite. The universe has a strictly limited supply of hydrogen gas, and every time a star is born, burns through its life cycle and dies, a fraction of that gas is permanently locked away in the ultra-dense cores of white dwarfs, neutron stars, and black holes. The fuel gauge of reality is dropping, and there is absolutely no mechanism to refill it. Eventually, the last massive blue stars will detonate in brilliant, isolated supernovae, leaving behind only the dim, red embers of low-mass dwarf stars. These red dwarfs are incredibly efficient, burning their fuel at a miserable slow crawl for trillions of years. But even they are subject to the unforgiving laws of thermodynamics. One by one, across the sprawling expanse of Milkomeda, these dying embers will flicker and extinguish, plunging the galaxy into permanent darkness. The era of starlight will come to a definitive end. The only objects remaining will be the dead husks of stellar evolution, freezing black dwarfs, rogue planets wandering aimlessly through the pitch black, and the silent, crushing gravity wells of black holes. The universe will enter the degenerate era, a period of time so unfathomably vast that our human brains completely lack the biological architecture to even comprehend the numbers involved. In this freezing, pitch-black epoch, the laws of physics will dictate a slow, agonizing dissolution of complex matter itself. Theoretical physics suggests that protons, the fundamental, heavy building blocks of atomic nuclei, are not eternally stable. Over timescales spanning 10 to the power of 34 years, protons themselves may begin to decay, dissolving into lighter subatomic particles and faint, meaningless flashes of radiation. If proton decay is real, then the very physical structure of dead planets, shattered moons, and frozen asteroids will slowly dissolve into a thin, invisible mist of subatomic dust. The only structures capable of surviving this slow-motion atomic disintegration will be the black holes. They will stand as the final monuments of a dead reality, silent, invisible monoliths, holding court over an absolute vacuum. But the universe is relentless, and even black holes are not granted eternal immunity from decay. In the 1970s, theoretical physics proved through the bizarre rules of quantum mechanics that black holes are not entirely black. They slowly, imperceptibly leak thermal energy back into the universe, a phenomenon known as Hawking radiation. It is a process of agonizing microscopic evaporation. For a supermassive black hole containing the mass of 1 billion suns, it will take roughly 10 to the power of 100 years to fully evaporate. That is a Google of years. A number so staggeringly immense that if you were to write a single zero on every single atom in the observable universe, you would run out of atoms long before you finished writing the number. Over this unfathomable stretch of deep time, the black holes will slowly shrink, their event horizons bleeding faint heat into the absolute zero of the void, until they finally disappear in a microscopic flash of high-energy photons. Once the final black hole evaporates, the universe will achieve its ultimate, inescapable state, maximum entropy. This is the heat death of the cosmos. It is not a death by fire, but a death by perfectly distributed equilibrium. All energy, all matter, all heat will be smeared so incredibly thinly across the hyper-expanded fabric of space that no thermodynamic work can ever be performed again. The temperature of the entire universe will flatline at a fraction of a degree above absolute zero. There will be no light, no structure, no chemistry, and no variation. But the most terrifying consequence of maximum entropy is not the darkness. It is the death of time itself. Time is biologically and physically measured by change. The ticking of a clock, the radioactive decay of an isotope, the orbit of a planet, the firing of a neural synapse. When the universe reaches perfect thermodynamic equilibrium, when every single microscopic point in the infinite vacuum is exactly the same temperature and holds exactly the same properties as every other point, nothing can ever change again. Without change, the fundamental arrow of time ceases to exist. The universe will freeze in a permanent, infinite, static state of nothingness, a dead mechanism floating in an endless dark, long after the very concept of history has been erased. When you return to your daily routine, the terrestrial illusion will inevitably reassert itself. The sun will rise, the streets will fill with familiar noise, and the immediate pressures of biology and society will desperately try to convince you that this world is the center of the narrative. But you now possess the irreversible burden of perspective. You know the exact mathematical scale of the lie. The machine suspended at Lagrange point 2 did not just capture the red-shifted ghosts of ancient light. It reflected our own profound irrelevance back at us. We built a flawless golden eye to peer into the mechanics of creation, secretly hoping to find a system that validated our existence. We hoped to find a universe waiting for our mathematics to domesticate it. Instead, we found a cold, hyper-expanding architecture of impossible galaxies and crushing gravity that does not know we are here and will never record our passing. Human history is nothing more than a momentary friction of carbon-based matter clinging to a cooling rock. Our greatest empires, our most devastating wars, the absolute totality of our art and science, these are not cosmic milestones. They are a transient chemical reaction taking place in the briefest fraction of a second before the machinery of the universe permanently freezes over. We are not the universe experiencing itself, as philosophers have desperately claimed. We are a localized glitch in a system accelerating toward maximum entropy and absolute silence. A million miles away, locked in the freezing shadow of its sunshield, the telescope will patiently continue its work. It will meticulously record the death of ancient stars and the anomalous growth of supermassive black holes, entirely indifferent to the existential panic its data has triggered. It is a machine devoid of ego, perfectly engineered to observe a universe devoid of purpose. Long after our oceans have boiled away and our brief technological era is erased, that monument to our curiosity will drift blindly through the dark. There is a profound temptation to extract a comforting moral from this abyss. To claim that because the universe is violently vast and empty, the fleeting moments we share on this planet are somehow infinitely precious. Do not insult the sheer scale of the cosmos with such biological coping mechanisms. It is the arrogance of a primate trying to negotiate with infinity. The universe does not care about human resilience. It offers absolutely no compensation for the psychological burden of consciousness. The void is not a canvas for human sentimentality. It is the executioner of it. Look up at the night sky tonight. Do not let your mind fall back into the comforting illusion of a celestial neighborhood. Understand exactly what you are observing. You are looking at the bleeding edge of a cosmic quarantine zone, actively pulling away from you faster than the speed of light. You are standing in the slow-motion wreckage of a cosmological explosion, helplessly watching the final pages of reality burn to ash. There is no grand destination. There is no final equation that will make the math balance. There is no ultimate revelation waiting to be deciphered in the deep infrared. There is only the silent, unforgiving expansion of the dark and the inescapable certainty that we are absolutely nothing.